Welcome to RamZland. Today I want to share with you Robert Boyle's gas law by using a wine bottle vacuum pump. Check this out. So if you remember, in 1661, Robert Boyle illustrated his gas law, which states that there's an inverse relationship between pressure and volume. So he said if the temperature of a gas remains constant, as you apply more pressure, you decrease the volume of a gas. But as you decrease pressure, you increase the volume of a gas. Check out how you can illustrate this with a balloon in a wine bottle with a simple vacuum pump. Okay, so to illustrate Robert Boyle's gas law, I'm going to put a deflated balloon into the neck of my wine bottle. And then when it's mostly into the bottle, I'm going to put just a tiny bit of air inside. And I'm going to tie off the end. So I know there's just a little bit of air inside my balloon. And right now I know that there's 14.7 pounds of atmospheric pressure per square inch at sea level that's acting on this balloon. I'm gonna use a pen just to push it the rest of the way into the bottle, hopefully without popping it. Okay, so there it is in my bottle. And you can see with that 14.7 pounds of air pressure per square inch, there's a lot of pressure on this balloon, atmospheric pressure, so its volume is fairly low. I want to increase that volume by decreasing the air pressure inside this bottle, and that's where this wine bottle vacuum pump comes in. So when you open the box, you have the pump that looks like this, and every time you draw back on it, it's pulling air out of the bottle. And then you have these attachments. So I'm gonna take one of these attachments off, and there's a little valve inside of it. So I'm gonna put that into my wine bottle, like so, and then I'm gonna attach the pump, and watch what happens to the volume of the balloon as I decrease the air pressure inside the bottle. Something is gonna happen to that balloon. And I can already see that it's getting larger. And all I'm doing right now is I'm decreasing the pressure inside the bottle to increase the volume of the gas inside the balloon. So I'm gonna keep drawing some of that air out until that balloon is obviously too large to fit down the neck of the bottle. You can already see this getting larger. I'm gonna keep vacuuming air out of the bottle. And it's getting larger. Okay, at this point, you can definitely see that the balloon would not fit down the neck of the bottle. So if I press this little valve, then that will allow the air pressure outside the bottle to rush in. So if I increase air pressure in here, then I'm gonna decrease the volume of the air inside the balloon, and the balloon should get smaller. Check it out. It completely deflated. So did any of the air in the balloon really come out, or were the air molecules just pushed closer together? So the same amount of gas is in the balloon when I vacuum the air out as there is when I let the air pressure outside the bottle rush in. The same amount of air is in the balloon. I just put more pressure on the balloon so it got smaller. Its volume decreased as pressure increased. And again, if you put your vacuum pump on there and you draw air out of the bottle, now I'm decreasing pressure in the bottle, so the volume of the gas inside the balloon increases. And the balloon starts to magically get larger. Here it is. Okay, now I'm gonna press on the valve again and watch the balloon get smaller. As I increase pressure on the balloon, I decrease its volume. Isn't that cool? So you can try this experiment at home by just finding your own wine bottle vacuum pump on Amazon, and it looks like they're as low as $14.99. So all you need is just a vacuum pump, a 12-inch latex balloon, and an empty wine bottle. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed enjoyed this presentation, be sure to remember to like and subscribe.